Good afternoon, day 7. We are going to do the first experiment. As per our syllabus, you know already the first experiment name is estimation of HCl, hydrochloric acid, using standard oxalic acid. Okay. So for the first experiment, we need to know about the makeup sample. Already you know very clearly in the demonstration class, I gave the live demonstration for make up the solution. Okay, the same way you can make up here. So before that, we must know the short procedure. So for the short procedure, it's easy to remember to write the exam as well as to do the exam in simple way. So first, you can make the table column as like Buret solution, Piper solution, addition reagent, indicator, endpoint. That is the first column. Okay. In the second column, titration 1, and third column, titration 2. So as per the titration 1, Buret solution is sodium hydroxide, Piper solution is oxalic acid, addition reagent, no addition reagent, indicator, not filling, endpoint, appearance of film. As per the same titration 2, Buret solution is sodium hydroxide, Piper solution is HCl, addition reagent, no addition reagent, indicator, not filling, endpoint, appearance of film. Okay. As per the first citation, we can call it the standardization of sodium hydroxide. So the given sample is HCl. Okay. HCl sample they given, the bottle number is 2. Okay. So whatever the sample given, we are going to find out the normality as less amount of HCl present in the given sample, which we are going to make up for the 100 ml. Right? So for this one, given sample is Na voltage. Whatever the sodium hydroxide given, that is Buret solution. But the normality of the sodium hydroxide also they didn't give. So we are supposed to find out the normality of the NaOH first. We can call it the standardization of sodium hydroxide, or whatever the standardization of the Buret solution first. That's why first iteration we are going to do the NaOH versus oxalic acid. Oxalic acid, we didn't label it the normality, but it's a given normality. Okay, so we are take the oxalic acid in solid 1 and then make up with the known normality, that is 0.1 normal oxalic acid body to standardize the sodium hydroxide. Okay, so now we have to take the sodium hydroxide in the Buret. So before that, first we have to wash the Buret with the distilled water, rinse completely. Then we have to rinse with the Buret solution, whatever the sodium hydroxide. Okay, so then we have to fill it and keep it ready for do the experiment. Then only you can take the oxalic acid in the pipette. Pipette also you have to wash with the distilled water, rinse with the oxalic acid. Then you have to take 20 ml of oxalic acid in the conical flask. Then there is no additional reagent. Then we have to add the indicator, 2 to 3 drops. Then once we titrate again, the NaOH will get the color change, or the appearance of pink. Right? So first we just wash the pipette with the distilled water, just going to rinse with the sodium hydroxide. Okay. So take a little quantity of sodium hydroxide, just you completely rinse. Without rinse, just once we fill the sodium hydroxide in the Buret, so it will be dilute sodium hydroxide, whatever the given NaOH. Okay. So that is the reason, first of all, whatever the glassware which we are using for the Buret solution as well as pipette, we have to rinse the corresponding solution. So now rinse completely. Then we have to fill the Buret with the sodium hydroxide up to the maximum capacity of 50 ml. Okay. Once we fill excess sodium hydroxide, then we have to drain through the knob to fill the after the knob, whatever the glass tip is there. So that portion also supposed to be filled with the sodium hydroxide. Then only the volume which we are measuring from the Buret will be correct. Okay. So now you wash the pipette with the distilled water. Little quantity of the oxalic acid will take and then rinse. Okay. So the oxalic acid is known one. That one you can say ourselves we prepared with the known normality 0.1 normal of oxalic acid. Now we rinse the oxalic acid also the pipette. Now pipette of 20 ml. So already we washed the all the glasses. Just for the demo, once again we are washing all the things as per the procedure. So conical flask is ready. So we can use the mouth pipette also. It's not that much tedious concentration, just normal concentration. So you can use the rubber bulb to suck the solution into the pipette. This we can take up to the mark. Whatever the capacity of the pipette is 20 ml. Okay. So just we take the 20 ml of the oxalic acid and then transfer into the conical flask. So once you transfer, just you dip the tip of the pipette, then you take it out. You need not to blow it. Okay. So just you have to tip immerse in the solution, then you have to take it out. There is no additional reagent as per the procedure. Just add the indicator, phenolphthalein, 2 drops. Okay. Sometimes it may take 3 drops. It's enough. 2 to 3 drops phenolphthalein. Just shake while adding the sodium hydroxide from the beaker. So slowly you do the titration. You have to use both the hand. Okay. You can't use the only single hand for shaking or few seconds. Then you have to open the sodium hydroxide. It's not right method. Simultaneously, while you adding sodium hydroxide from the beaker, and then you have to shake the conical flask. Because without proper shaking of the conical flask, once you continuously add the sodium hydroxide, it may lead to excess sodium hydroxide in the conical flask, which show the color. So you may thought it was completed, but actually simultaneously you have to shake the conical flask while adding the NaOH from the beaker. Then only you will get the exact neutralization point when it's permanent pink show. Okay. So slowly you do, because we don't know how much volume of the NaOH required to neutralize the 20 ml of oxalic acid we took it out. So that is the reason we have to go slowly. The first time when you do any titration volumetry, slowly we will do. Then whatever the range when we get it. For the second time, we can go a little bit fast, wherever the range you got in the end point. Before the 5 ml, you can slow down dropwise to get the exact value, whatever we call it, the concordant value. Okay. So what is the concordant value? Already in our right? So successive titration value supposed to be same. Then only we call it the concordant value. Okay, the titration we have to continue until the concordant value. Once we get it, we stop the titration, note down the reading, then do the calculation. We can go for the next titration. Okay, so now it's going to get the end point, slowly doing the titration against the NaOH. So it's on the way to get the end point. Yes, it's a light pink. You can see the visibility, right? So very light color. It's not clear pink it's showing. So better you can yes, pink color. Actually the pink color, you can see the pink color, right? So yes, okay, you got the permanent pink color, right? So that is the reason when we are getting the pink color, you see how the pink. So that is more than enough. The color of pink permanently appears. So stop the titration, note down the value. So whatever the value it's showing, actually 25 point, actually due to the colorless, it's lower meniscus 25.5, right? You can note down the reading. First titration 25.5. Now we'll repeat once again. to get the concordant value. Okay, so now this time we can go a little bit fast also because we know the range of the end point where we are getting. So now in the starting 0 ml itself we need to go clockwise. Okay, now just the same way you can refill the sodium hydroxide in the beaker. So wash the contour first, then we have to put it out 20 ml oxalic acid, no additional reagent, indicator 2 to 3 drops, just we will repeat it. Okay, so very clearly we know the procedure for the standardization of sodium hydroxide. Yes, okay, so now lower meniscus with the matching the 0 reading for the burette with the NaOH solution. Now pick it out 20 ml of oxalic acid, pick it out for the second time using the rubber bud, because once we go with the mouth paper, so due to the acid we may go with the rubber bud. Okay. Now exactly 20 ml pick it out, there is no addition reagent, just dip and then take the paper. Now we take the indicator 2 to 3 drops phenolphthalein. Okay, the phenolphthalein acid will be discolorless actually. Once it's in the basic medium, okay, it will be the pink color. So all the acetic acid, whatever the COOH, it converts into the neutralization. So it's supposed to have the sodium hydroxide OH. Okay, so you get it in the OH, the contour pass basic, it will show the pink. That is the reason once it's appear the pink, immediately you have to stop. If you added excess to get the dark pink, that will be lead to wrong rating. So appearance of pink is the end point. Okay, permanent pink. So once it's now it's appearing, again immediately disappearing. So this is not the end point. So end point actually we call it appearance of pink color, right? But it's supposed to be permanent. Once you shake long time also it won't disappear. So appearance of permanent pink, once is there, we'll get the reading for the first citation. So we'll see whether we are getting concordant reading or different reading. So as per the school person doing the experiment, so they know very clearly where all the students do the mistakes, so they can easily eliminate the manual error. So doing the experiment so many times every day for the standardization or take the skill value, so they will get the concordant value in the second time itself. Okay. So they are doing very slowly because of reaching the end point. So whatever the end point, already we know down 25.5, right? So whatever the permanent pink, once we get it, we'll stop the titration. Yes, it started to appear permanent pink. Yes, okay. So very clearly we got it, the permanent pink into the, okay. So you can see the pink color, it's not, okay. Okay. Now you can see the pink, okay. So permanent pink, you got it. Now you see the burette reading, it's also 25.5, okay. So it's showing very clearly you got the concordant value, right? Lower meniscus 25.5, both the titration you got the concordant reading, so 25.5, you note down the reading, okay. So you can do the calculation now. So before that, so we have to do the second titration, okay. need the second iteration, then you do the calculation last. Okay. So for the second iteration, that we can say estimation of HCl, hydrochloric acid. So whatever the estimation of HCl, we have given sample is HCl in reagent water with the bottle number 2. Okay, we don't know how much volume they given. Normally they give the 9 to 12 ml. Okay, with the different bottle number. It may be from 1 to 27 as per the strength. So they will give 1 to 27 bottle different normal time. Even in the last fourth decimal, they may change the normality. Sometimes the third decimal. Okay, so not the too much variation. So we will not be able to guess the normality, because whatever we took it is 0.1 normal of the oxalic acid we preferred now, and then we standardize the sodium hydroxide. So we don't know now any other solution how much normality they given. Okay, so but it took the 25.5 ml to neutralize the 20 ml of 0.1 normal oxalic acid. Okay, now we are going to make up the given sample HCl. Okay, just we have to watch the standard flask which already shown in the demo class with the distilled water. Now we have to transfer the HCl into the standard flask. Then we have to make up with the distilled water. Okay, so already I told, once you transfer the sample, we have to wash the reagent water 2 to 3 times. Then only we have to add the distilled water into the standard flask. Okay, so just do it. We make up. The apparatus is getting ready for the next iteration. Washing the apparatus. Leave it not to wash. We can refill the sodium hydroxide once again. Okay. Now we wash the standard flask with the distilled water. So transfer the HCl into the standard flask through funnel. Then wash the reagent bottle 2 to 3 times with the equal quantity of distilled water. Then we shake very well the standard flask. Okay. This will transfer. Glass are used to transfer the solution without spilling. Okay. So whatever the solution we are transferring from one vessel to another vessel, directly if you transfer it may spill. Okay, so for that reason we use the glass jar to, without spill, to transfer into the particular vessel. But we can say that transferring the HCl from the reagent bottle into the standard flask, just you rinse it, because we may let one single drop only, but it may lead to more error, because the amount of sample given it may be 9 to 12 ml, but we are going to make up into 100 ml. Even that single drop, sometimes it may lead to 0.3 to 0.4 ml sometimes, right? So in that cases, so definitely going to be give the wrong answer, of course. So for that reason, wash the reagent bottle 2 to 3 times with a little quantity of the distilled water. Then wash the glass jar, wash the funnel inside the. Then you close and shake very well to the homogenize. Don't add the distilled in single stage. Close the lid and then shake very well to get homogeneous. Afterwards, you add the distilled water. Okay, in a single stage, if you add distilled water, you won't get the proper homogeneous solution. Okay, so until the neck you can add it. You can pick out the distilled water for the final makeup. Okay, now we shake very well to get homogeneous, because after the neck, when you add continuously the distilled water, sometimes it may be the top layer less, even though it's a completely visible one in the water medium, So it may be less normal in the top layer. So you have to shake very well before make up completely until the mark. Now you can take the distilled water in the flipper, then you can go dropwise to make up until the mark. If you add excess water, it may lead to the dilution of the HCl. That also give the wrong answer. Okay, so diluting sample may give the wrong answer. The picture without water sample, if you can go with the addition of water through the wall. It's giving very clear addition of distilled water, whatever amount we need. Okay, slowly this is add. Okay, dropwise. So clearly you can see it's a very slowly showing and then increase the level. Alright. So when it's come to the mark, due to the colorless, we supposed to keep the lower meniscus. Okay, so just like the lower meniscus, keep the standard flask into your eye level. Then only you can see very clearly the lower and upper meniscus. Okay, yes, exactly done the lower meniscus for the colorless. Now you can shake once again very well to get the homogeneous solution. You have to hold it in the another hand, then shake with the bottom. Then only it may give more space to get the homogeneous. So 2 to 3 times more than enough to get the homogeneous. So more solubility, complete visibility. Okay. Now sample is ready. Now 100 ml. You can do 5 times from this 100 ml sample. Okay. If you do the title by doing titles and the sodium hydroxide, if you added excess indicator, if you add excess direct solution, you can repeat 4 more times, no issue. But while doing the makeup, if you added excess water or if you left some sample in the reagent water, definitely you will get wrong answer. Any number of time if you do the titration against the sodium hydroxide, right? So makeup is very important. You have to carefully do the makeup. Even you can take more than 10 minutes to make up, no issue. Okay, so now makeup over. So to the period with the same lower meniscus sodium hydroxide, just you can fill at 20 ml. It's about you have to wash the pipette with the distilled water already. Okay, just you take little bit and rinse. So rinse and then take the 20 ml of makeup HCl sample. Okay, just we burn the rings. Okay, now you take it up. 20 ml of the makeup HCl sample. Transfer into the conic flask. Already conic flask wash. Just you can transfer the HCl. Okay, there is no additional reagent. Just you dip the tip of the first and then take it out. Then you can go for the addition of indicator 2 drops in our body. Okay. Now slowly do the titration against the sodium hydroxide. Okay. Endpoint we know very clearly appearance of pink points. Okay, pale pink. Because whatever the oxalic acid, typical solution last time, pure solution sodium hydroxide, we get the same endpoint. Here also acid base. First one is a weak acid, whatever you have is consume here 25.5 ml of sodium hydroxide. Now the HCl we made up, we don't know how much concentration they will in. So this one how much is straight away, we'll see. Okay, supposed to be the permanent pale pink color. So slowly doing clockwise to get the endpoint carefully. You don't know the range of the endpoint now, right? So you have to do carefully. If you added excess once again we have to refill the bivette and void the chemical flask and take the HCl 20 ml and then additional agent and then repeat. But without hurry to do the first 2 times itself, we can get the conformal. That means successive titration value is supposed to be same, right? So the waste of chemical avoided when you do carefully the titration. Yes, we are nearing the end point. So almost coming to the range of the still getting in there, but whatever the volume it comes to